Hi. So today we'll do introduction to differentiation. Uh, Differentiation is under calculus. What is calculus? Calculus, the Latin word of calculus means that small pebble. Okay, the small pebbles of the birds add up together and then it builds the nest. So calculus means small pebble. So the meaning of it is the study of small changes, infinite, decimally small. Okay, why? Who came up with calculus? So there was a debate between Newton, Sir Isaac Newton. He's a sir. He's the father of physics. Newton. Okay, so Sir Isaac Newton. Let me check on his year. He's a January kid. 1623 January 40401. He died in 1727. 1727 01 31st March. Both he's a king. He's an England guy. Okay. Now there's a huge dispute between whether it is really Newton who came up with calculus or Leibniz who was the one who came up with calculus. So we don't know about this. Okay. More on this you can find out on Google. But why do I attribute it to Newton? Is because he was the one who extensively used the idea of calculus from mathematics and he used it on physics. And everything that we are using today is thanks to his work. Okay, so he was the one who said F equals to not MA, not F equals to MA. He said EP over D. Okay, so this is calculus, this is differentiation. The story goes, he wanted to explain some force, but then he couldn't explain it, and then he come up with a whole set of calculus in just at the age of 26 to actually explain the whole concept of motions, kinematics, and later on gravitation, optics, sounds, whatever, everything in physics. You will see Newton somewhere in physics and in mathematics. Leibniz is said to be one of the greater, one of the greater guy also, but sorry, I don't have enough information on this. Okay, so why do we learn differentiation? It's because we will learn optimizations, we will learn small change, we will do engineering, we can create this kind of talk, this kind of machines that we can talk, the laptop, the phones, the cars that you use, everything is built on differentiations and calculus per se. Okay, so this is what is calculus. This is why we learn calculus, and now is how to do calculus. So how to do well in calculus? Okay, you need three things. First, definition. Second, techniques. Techniques are like if y equals to x squared, then dy over dx is equals to 2x. You have d over dx of sine x equals to cosine x. If you have a fx is equals to, let's say, 1 over x, I mean ln x, you will have f prime x equals to 1 over x. Okay, so those are techniques. And then you have you later on you will have implicit differentiations. You have a partial derivative. Oh, by the way, differentiation calculus, this one, differentiation, integration. How to do well in calculus? Okay, let me rearrange this. Okay, differentiation should be under here. How to do well in calculus? Okay, how to do well? You need to do well in both differentiations and integration. Let me also select. Differentiations and, sorry, integrations is here. Today we'll not touch on integrations because we'll just focus on. So integration is another area that we need to, pun intended, integration is another area that we need to focus on later. Differentiations derivative. Okay, so this one, erase. You need definitions, you need technique. Okay, you have implicit differentiation. You have partial derivative. Partial derivative. Later on, when you go way higher in mathematics, you will learn Hessian matrix. You learn gradient boosting, gradient descent. You learn contour plot, where you see all those altitude in geography talking about height, and then you'll see different area. All of this is thanks to differentiation. Okay. Okay, so applications. Okay, so applications are, the easy applications will be tangent, normal. I will explain later why. Optimizations. Of course, kinematics, the study of motion. That's the whole purpose of why calculus was invented, to solve problems related to motion, kinematic. Okay, and then you have a rate of change, you have a related rate of change, related rate of change. Okay, you have more and more. Then later on you have neural net. Okay, so way later you have neural network. You have machine learning. Okay, where you optimize which one is the best way to solve problems. Okay, contour plots. Then you have applications in economics. You have applications in physics. You have application in geography. Even sociology has it. Why? Because everyone tends to go, okay, not everyone, majority tend to think in a certain way. So with statistics, okay, statistics, you have tests, you have everything related. You will need calculus somewhere. And this will lead to sociology, when you learn the majority or like some proportions of the population do certain thing. Okay. Anyway, that's too much about techniques and applications. I will now go deep into the definitions of what is differentiation or derivative. The definition is uh, the study the change or rate of change rather of a variable with respect to the change of other variable. Okay, so what is change in mathematics is delta. Delta is stand for change. And the formula for change is final minus initial. Final value minus initial value. And that's why when you do the gradient of a line, you have here y x final, y final, and here is x initial, y initial. The formula for gradient, which is m, is delta y over delta x is y final minus y initial over x final minus x initial. Basically, it is a change in the y direction over the change in the x direction. It will measure the slope, how fast it increase, how fast y is going to increase when x increase. Okay, negative slope will mean y will decrease when x increase. Okay, now, but that's too easy. We don't need differentiation for that, but we will use that to understand differentiation. Now, I have here my curve y equals to x squared. Just some naming conventions. I'll call this y equals to fx. Therefore, fx is equals to x squared. Okay, and so this curve is y equals to x squared. This is y. This is x. Now, say I want to find the rate of change of the curve at this point, particularly. What I'm gonna do is I want to find this and the very, very, very small change next to it, which is gradient of a tangent. Okay, so gradient of a tangent. Oh, that's the bad tangent. Okay, gradient of a tangent. But how do we find the gradient of this tangent? We don't know. With normal mathematics, we don't know. Without calculus, we don't know. Okay, but what we can do is we can imagine. A curve. I mean a line, and we let it be a tangent. Not true. This is called secant. It's not really a tangent, but here you have an x, and here some delta x distance mean changing in x. Some delta x distant away, you have x plus delta x. Right? X plus delta x is delta x different distance away from x. Okay. So this one, if you plug fx, if you plug x into fx, you will have fx into output is fx. Okay, so here is fx. And if you plug x plus delta x into fx, you will have f bracket x plus delta x. That's how a function works. Fx plus delta x. If you don't see it, why, you can refer to the function video. If you don't see why, then you will need to refer to function video where I explain how a function works. Okay, it's a prerequisite for you to understand calculus. So please learn function before you go into calculus. Okay, next, what we have is we're gonna find the gradient of this tangent. M over secant, secant equals to delta y over delta x equals to y final minus y initial over x final minus x initial equals to, now y final is fx plus delta x. Okay, yeah, y final x plus delta x minus y initial, which is fx, over x. Basically x final minus x initial will just be delta x. Okay, I'll bring back delta x. Okay, now what is this? Because y fx is equals to x squared, right? So f, again, we have to use functions idea. So if you really cannot, you have to go to functions topic to understand what is going on next. So now you have x plus delta x whole thing squared minus fx, which is x squared, right? Yeah, because fx is x squared. So yeah, so this one is delta x. We open up now. Remember this: a plus b whole thing squared equals to a squared plus b. 2ab, sorry, plus b squared. And if you don't understand this identity, I will have a video, but if you don't understand this algebraic identity, you need a few more years to understand calculus. Sorry to say that, but that's just a hard truth. Go and learn the algebraic identities first. Identity. Okay, there are about 7 algebraic identities that you should know. Okay, so this one, if you open up x squared plus 2x delta x plus delta x whole thing squared minus x squared over delta x, you simplify, you will have, I will cancel this, I will have 2x delta x plus delta x whole thing squared over delta x. And if I factorize, okay, to simplify fractions, you factorize it. To simplify fraction, you factorize it. And of course, I will have another video on this concept, okay, or rather technique. Okay, so now delta x bracket 2x plus delta x over delta x. Okay, so and then here you can cancel, and here will just be 2x plus delta x. So basically, the gradient of this secant will just be 2x plus delta x. The math check out. The math check out. And you may see 2x somewhere in your technique. When you differentiate x squared, you have 2x. Okay, so what is the last part that proves differentiating x squared give you 2x? Okay, now let's zoom in this diagram. Right now, what we have is this exaggerated tangent is actually a secant. Okay, so this one is secant 1. Secant 1. Then if I do it this way, you have a secant 2. You know that it is closer to a, this one is delta 1, delta x1. This one is delta x2, which is smaller. And if you do smaller and smaller, you will eventually get the tangent, right? Where delta x is, okay? You will get the tangent where delta x is 0. very, very close to 0. A change cannot be exactly the same point, so it has to be the next point. But you will have it very, 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 very close to 0. I drew 2 points here, but it's actually kind of at 1 point because the distance is 0. But not really. It's x. Here, very close to it, you have x plus delta x. And here is delta x equals to 0. Oh, sorry, not equals to 0. Hence to 0. Get very close to 0. And now then you have a tangent. Okay? So let's go back to this. We push delta x to 0. We'll call this limit as x tends to 0. Again, another video on limit. Okay, and I lied to you about differentiation and integration. There's one more part. How to do well differentiation, derivative, integrations, you need to do limit. That will come in the next video that you will watch. Okay, yeah, the limit video. Okay, so now if I add limit, I will have dy over dx instead of delta y over delta x. Dy dx is when delta y delta x is pushed to 0, very close to 0. Limit as delta x goes to 0, limit as delta x 0 dy dx, limit goes to 0, dy over dx, limit as delta x goes to 0, dy over dx, y over dx, limit as delta x goes to 0, dy over dx goes to 0. And here you will see that this one is 2x plus delta x that has gone to 0, dy over dx. And then dy over dx is equals to 2x, or y is equals to x squared. Okay, so again, this is calculus, one of the biggest revolutionary discovery, or rather invention, by the duo Sir Isaac Newton and Leibniz. Okay. Your homework for you to try is gonna be, this is called by first principle, derivative by first principle. All right. Okay, there will be no homework. I'll end the video today. Yeah. Okay. Bye bye.